Okay. Hello, everybody. We are the parallel processors, and we are very excited to be sharing our final project with you. Now, what does our project do? What is our goal? Why does it matter? Well, our goal for this project is to be able to create a model that can classify whether or not a person has diabetes by using a data set that includes several health levels, such as glucose, insulin, age, BMI. Our team is able to train our model to identify the symptom levels of diabetes. However, which levels are the most correlated factors to whether or not an individual has diabetes? The person that will be answering that is my amazing teammate, Landen.
So for our exploration of data section, a heat map's main purpose is to display the correlation between features in a data set. If you look below, you can see all the features, glucose, BMI, etc., and the correlation to the outcome. We use the info on the highest correlation, which is glucose to the outcome, but we didn't use all of the information for the main project. Harel's section now.
All right. After the heat map, we made a box plot to find the outliers in our data set. The rectangles show the average for each variable. The singular dots are the ones we would consider abnormal or the outliers. We use this type of visual to see the outliers in our data set, and this was important because these outliers can decrease the accuracy of our data set. So once we removed them, naturally the accuracy went up. After this, we had scatter plots. So after we made scatter plots to see the correlation between two variables, one of which was the outcome. Scatter plots are useful because we can see certain variables have a higher correlation than others. These people are the ones who have diabetes. We also use scatter plots because the features were numerical, which is visualized better in scatter plots. Now I'll pass it off to Rocco.
Logistic regression is used when predicting an outcome based on a fixed variable, such as determining possible risk of disease using health factors like glucose level and BMI, body mass index. Before predicting an outcome, filtering through data is usually the best course of action because it allows faulty data to be discarded, such as if the data set displays someone's blood pressure as 0 or 400. The logistic regression accuracy that we got was 84.6%. The confusion matrix shows that there are about 11 false negatives, which is a very bad number when dealing with medical diagnostics.
K nearest neighbors takes a data point and finds like a K number of points next to that data point. So for example, if K was equal to 5, K nearest neighbors would find the 5 nearest neighbors and chooses the class of neighbor that has the majority. Because K nearest neighbors chooses a majority, K cannot be an even number because there's a possibility for a tie. In this data set, I tested many different K values and we found that K is equal to 47, gave the highest accuracy with 85.9%. Looking at the confusion matrix, there are 10 false negatives. In the future, I'd like to reduce that number.
So random forests work by making like decision trees and then passing a data point through each one of these trees for an outcome. And then basically it just averages all of the outcomes from all of the trees to make a final result or classification and final class. So to increase our accuracy of the thing, we took out some outliers and applied like the most relevant points with like a range of insulin, for example. And we got the accuracy to be around 80.7%. And from the matrix, you can see like it's pretty accurate, but there are 9 false positives or negatives, which is not that great.
Okay. So now for our conclusion. Based on the results, our team has come to the conclusion that K nearest neighbors has performed the best compared to all machine learning models. With cleaning the data and handling the outliers, all models were able to get to significantly high accuracy points. such as logistic regression got to 84.6, k-nearest neighbors got to 85.9, random forest got to 80.7. However, it is important to keep in mind that although k-nearest neighbors resulted in the highest accuracy, it was random forest that had the best recall, meaning it had the highest chance of accurately diagnosing the symptom levels for diabetes. Now, since our data set is not the most significant and recent research, including a good amount of false negative values, further research must be done in order to use this model in the real world. However, with more recent research and data, this model could be able to prevent people from experiencing harsh effects of untreated diabetes, along with helping people try and reverse it. If our model is able to point out diabetes early enough, then the individual has a chance of reversing their condition. Thank you for listening, and that is our presentation.
Yes, and then I also just want to shout out everyone on my team. They were all first-time coders, so being able to do all this is just really incredible. So I want to shout out to Harel, Yifan, Rocco, Hari, Tatiana, and Landen. And then last but not least, we put in our bang-in parallel processing playlist that we played throughout this camp. It's just something that we bonded over, and we wanted to include it on our final website.